Good evening, everyone. We are super excited to have you all here. Today we have Kanchana Wickremasinghe, who is a Vice President and Product Manager at WSO2. He's going to talk about Kubernetes Security Pattern. Kanchana, screen is yours.
All right, thank you for the lovely introduction, Chamod. And let me share the screen. And while I'm, trying to find the right screen and share it, good afternoon and good morning to everyone, wherever you are joining from. Lovely to have you all here in the Kubernetes meetup. I think we're nearly getting close to the third year now, right, Chamod? If I'm not mistaken, yeah, in the third year. So I'll go full presentation mode. Hopefully I will not lose the screen. Okay. Screen is visible. I'm assuming, Shamot, coming up okay?
Yes, Kanchana is visible.
Okay, all right. So today I'm going to take you through how to apply security in the Kubernetes clusters, the applications and services that you are running in Kubernetes from a slightly different perspective. A lot of the time, I think we tend to jump at tools first before we look at what things actually need to be really secured or what things need to be solved in terms of a problem. So hence why kind of driving from a pattern perspective to see what security that can be applied on a Kubernetes cluster and giving you some tips and tricks in terms of how to apply them, what tools to look at, and so on and so forth. So let me, without further ado, let me get started. So firstly, for some of you all probably joining for the first or second time, just a quick rundown of the Kubernetes architecture. So as you can see, in Kubernetes, there are many components. I haven't obviously drawn all of the components, but I have tried to summarize most of the components. So let me start with the Kubernetes control plane, which is also called Kubernetes masternode, but I like to keep it as the control plane, which is what Kubernetes organization themselves and everyone else is now starting to refer. Worker nodes or the workload nodes, you can have one or many. I have only drawn two here, but I have kind of given you the understanding of what it needs to create a Kubernetes cluster and what you will have minimally. So from the control plane perspective, you have multiple components, and mother of all that is the Kubernetes API. Let me see if I can get the pointer. There you go. Yeah. So that's the Kubernetes API. And then you have Kubernetes Control Manager and the Cloud Control Manager, which is optional. You sometimes have it, you don't have it. Mostly, if you are actually running on managed Kubernetes, you would have that. And then you have the etcd, which is your key value pair database, where it stores all the configuration and everything about what you apply on the Kubernetes cluster. And then the scheduler. And in the worker nodes, of course, as you all obviously know, you have one or many pods. You have kubelet, which runs as a daemon within the worker node, and then you have the kube proxy, which control all the traffic in and out from the worker node. You have container runtime. I didn't draw this as Docker. Everyone keep referring to this as the Docker runtime, given that now Kubernetes is not put in Docker as the runtime. You can have Containerd or Creo or any other ones that you would like. I like to keep it as the container runtime. So you would have the same on the other node as well. And like I said, you can have one or many pods. And everything from the Kubernetes control plane communicates via the API into those two nodes. Right? And how do you access? You access either through a GUI. It could be a GUI that you'll have developed, or it could be a GUI that, like the Kubernetes dashboard, or a tool like Platformer Console, or Rancher Console, or any other UI. Right? And then you also have the mechanism of accessing it through command line, which is the CLI. Typically, the standard one everyone uses these days is the kubectl, or some people call kubectl, is another way of accessing the Kubernetes cluster. So I'm going to take you step by step from left to right in terms of what are the security touch points or patterns that you need to start thinking about before you jump onto tools and start applying the tools. Now, by the way, please feel free to ask any questions, and I'm happy to either take them at the end, or I'm happy to be interrupted and take it while I'm presenting. The first one is an escalation of privileges. So how does an escalation of privileges happen? Sometimes from the left, accessing either via the GUI or the CLI, especially the CLI, which is the kubectl, people tend to share the same Kubernetes config, or another method of kind of lazy approach is you have a single bastion host, bastion host that everyone access to, and then everyone basically get the same access of the kube config. What happened is at that stage, you have full access to the API, and you do have full access to the cluster. You can do practically anything that's running or anything that is operating in the cluster, right? So if this escalation of privilege happens, so I guess if this happens, you get full access to the Kubernetes cluster, right? If it is an empty cluster, of course, there is nothing to worry about it. But 99% of the time, you actually have something running in the cluster. A very good example was what happened with Tesla. Somebody had the Kube API exposed and did not even have any, access tokens given to it. Right? It was actually through the database. To the dashboard where they had the full access. So what can happen? You expose the data, you expose the secrets, and hacker can pretty much do whatever she or he likes, right? How do we prevent this, right? Never have the Kube API exposed publicly. So try and create, whether you're creating in the public cloud or whether you're creating in your private environment, have the Kubernetes API only available privately. If it's a public cloud, private VPC. If it is on your prem, do not expose with the Kube API directly, because people are too lazy to do VPN or come through another firewalling rule or something like that. Right? Also, if you are even in the private environment, never share the kube config. Right? Couple of places which I can't obviously name. What has happened is they have had contracting staff coming in to do work, and they have left in their laptops the kube config, which means they have full access. Obviously, they didn't do any damage, but that was kind of violation of the access rights that they have. And extra precautions to take when you are using bastion host in Kubernetes, like I said, do not have the same access rights given to everyone who is accessing their host. Right? Even though it is in the private environment, make sure they have their own credentials and they have their own kube config and they have their own RBAC in terms of what they can do and cannot do in the Kubernetes environment. Right? Okay, so going into the next slide. Missing or lazy RBAC, I call this one, access control. Again, very similar to the previous situation, but a little bit less, I guess, in terms of the consequences. This is where you pretty much give everyone kind of very similar RBAC access into the Kube API, right? Again, they may only be able to access certain pods, but they can expose data, they can extract the secrets and so on and so forth. So like I said in the previous slide, if you are going to allow multiple people access the Kube API, never share the same Kube API with others. At least start with the least access required. And also the best practice is to either combine with your Active Directory, which is called AD, or Identity and Access Management Policies and Procedure. Like if you're on Google or AWS, use their IAM. So at least you could prevent, me versus another person having the similar access. Again, you do need to be cautious around the IAM, not give everyone the same rights. Then it kind of, again, defeat the purpose. It becomes very similar to how you would access the kube config, sharing the kube config, right? Moving on, unsecured etcd. Again, this is something that when you start, deploying your Kubernetes cluster, you need to think about, how you're going to give access to the etcd, because etcd is kind of like your private repository of all the configurations and things that you store with regards to the Kubernetes cluster, right? If someone has access to it, they can reconstruct what is required to access the Kube API. So they could create their own kube config with that, and then practically get access to the cluster. They may not originally have access to the Kube API, but if they have access to the etcd, because they happen to be a user who can SSH into the control plane node and get access to etcd. So when you are doing that, secure it by default. When you're creating the Kubernetes cluster, secure etcd by default. Only create separate accounts, separate service accounts, ideally, for backup and restoration of etcd. It's really important to backup etcd, but use a automated system account to do that, and give that particular account, whether it's human account or system account, the minimum required to access the read-only access to etcd, and to do the backup. And that also have to be kind of monitored and observed as well. Just because you have that, don't expect that it's fully secured. So I'm just checking to see if there are any questions at this stage, or am I going too fast? If it's not, I'll guess no questions so far, so I'll continue. Chamod, are there any questions, or am I going too fast? Or?
No questions so far.
Okay.
Guys, if you have any question, please drop them in the chat.
Okay. I'll continue then.
Yeah, go ahead.
Okay. All right. So the next one is where I call it poor or no access control. Now it is down to the lost the pen again. Now it's down to the actual workload that's running within the Kubernetes cluster. Right. So imagine you have a pod which is running a service with unclassified data. Data that does not need to be classified. There is no personally identified data like name, email address, your bank credit card, or things like that. So that pod, the service account that have access to that pod is set up in such a way that can access the pod next to it or pod in another node as well. that has classified data. So what happens is if these two pods are spun up using the same service account, one could get access to the other pod which has the classified data, like personally identified data, or it could be even financial data without personally identified data, but it is classified that only should be seen by certain people or certain services and so on and so forth. What that means is somebody could run like a bot or something on this particular pod and then get access to the other pod because it's using the same service account, right? Which means you are now having to access all the classified data, and it's even get worse if the classified data in that pod was unencrypted. If it was unencrypted, the person or the system accessing that pod can access that data very easily, right? So so poor or no access control with unclassified data in the pod with classified data, right? So this pod can access anything in that data in the other pod. So this leads to data breaches, right? And several companies have had that, and it's surprise, even banking sector and some of the others. They only think about once something happened. Luckily, a lot of things haven't gone externally because each country's privacy laws are getting stricter and stricter now. So they need to report something like that happened, but it does happen. So you can take precautions to avoid that. And again, risk of compliance as well. It could be a service internally, so it's not a service that's externally. But if that service from a, let's say, regulatory compliance not supposed to see that data, that means you could actually in breach of compliances, right? So how do we prevent these kind of scenarios? Some managed providers like GKE and EKS and even Azure to a certain extent provide the identity at the pod level. So you have different identity for each pod, and you define what they can do and what they can't do, right? So that way, this pod A, let's call it pod A, cannot talk to pod B and get the data. Even if we did, it probably can't read the data because data is then encrypted, right? Also have make sure that secure pod-to-pod communication. Kubernetes, because it's, keep everything simple, pod-to-pod communication is normally HTTP, so it's very easy. Another pod to listen the traffic between the two. They can easily spun up a pod that's running and listen to the traffic that's going between. So it could be this pod listening to the traffic going between these two and capture everything, right? So have it secured at the Kubernetes network level, or the service can encrypt the data itself, right? So it's called encryption at transit. And also, if the data is ever stored in the pod, even for temporary, ensure that it's actually encrypted at the rest as well. Enable traffic policing. So things like OPA or Gatekeeper, and there are other commercial products as well, Calico, Zillium. They have tooling that will allow you to stop pod A unnecessarily talking to pod B, right? And you can set up alerting and so on and so forth as well. It's very important you have practically secured from this end, but unknowingly now you actually have a vulnerability inside, right? This is all okay if you're running in development or you're running in your own laptop or so on and so forth, but in production, imagine what can happen. The next one is the network segregation and encryption, which is kind of related to the one I told you before. But this one, let's assume that we got 3 namespaces and each one has one pod, right? Yeah, it's nice and easy to identify which pods are running in which name services, namespaces, which is great. You've taken the first step. But if you did not specify that namespace 1 cannot talk to namespace 2 or namespace 3, you can easily spin up a pod that talks between all the 3 namespaces. And also, like I said earlier, the pod running in namespace 3 can spin up a pod very similar like Wireshark or listening to the traffic and listen to the traffic that's going between the 2 pods, right? And if they are communicating between the 2 unencrypted, it's in clear text, right? Consequences, of course, data breaches and risk of compliances, very similar to what's happened in the previous one, right? Enable secure pod-to-pod communication. Like I said earlier, you can do through the CNIs, or you can encrypt using the service. Right? Enable traffic policing. So this is allowed, let's say, but this pod in this namespace is not allowed to talk to or listen to this one, right? Which means even though they might be trying it, they may not be able to see it, right? So you can separate them. So segregate the network, segregate how you actually talk to each other, and also most importantly, make sure that they're communicating securely. Don't take it for granted that Kubernetes is internal and it will securely communicate. So far, so good. No questions, Chamod?
One question.
Yes, yeah.
Can containers sensitive volume and directories?
Okay, so containers can mount volumes and local host paths, but should you do that? If you're going to do that, make sure that they are encrypted, right? That's one option. The other one is if you're going to do sensitive stuff, have them in memory, right? That way, inject into the memory. That way, you're not actually, even if the pod dies, you're not accidentally leaving them. Because what could happen is you could have a persistent volume created, and then you could have a volume mounted, and then you would write sensitive data to it. You would kill the pod, and you've forgotten to delete or get rid of the persistent volume. You should always have if you're going to do that, you need to make sure that you actually delete the persistent volume as well. But quite a bit of the time people forget. So to do that, if you're ever going to use the persistent volumes, PVs and PVCs, make sure the sensitive data, if you have to store it encrypted. So only the service with the right key can access that data. So you could use things like HashiCorp Vault to do that encryption and decryption to read the data by the service, but no other pod spinning up will be able to do that. I hope that answers the question, Mohammed. That's the only one we had so far, right? So, any more questions? Or shall I keep moving on, Chamod?
Yes, go ahead, Kanchana.
Okay. Poison image, very well known to these days, right? A lot of the time people download images from Docker Hub. And if you look at it, Docker Hub got millions and millions of images, and most of the time, without knowing, they have vulnerabilities within them. Right? The sad part is if you run that in your environment, that could potentially, depending on obviously the severity of the poison pod, it could give control to a hacker. Right? That means, unknowingly running that image on your cluster, you are practically giving away full access to your cluster, and you may not even know. And they could come, just, like crypto mining guys, very famous for having pods that seems very sincere and genuine, and you run it, you're running your application, you think that's all you're running, and you ended up running other things as well, right? So they can take control. Once they take control, as the previous slides I explained, you can practically do anything you like, right? They can poison the other pods or services you're running. They may not do an immediate harm. They might actually, run things that you're not supposed to run in your other services and pods, and your customers might be very unhappy about it, right? So how to prevent this? Apply some of the stuff that I already discussed about in the previous slides. But even if you're a small startup, start thinking about having a private registry. So you get scanned, vulnerable, free images into that registry, and you only allow your developers to deploy from that image registry. So OPA Gatekeeper is a really good tool, and you can run a policy saying if the image is not from, for example, let's say star.wso2.com, it will fail to deploy into the cluster, right? Always do binary static image scanning. There are open source tools like Trivi and Falco and so on and so forth that allows you to do that. If you wanting to have commercial tools, Cisco, Sysdig, Falco, EchoSeg, New Vector, some of the ones that allows you to do static scanning. I think Mohammed did ask another question. Agree that we need to have the Kube API server support. Wasn't the case. Is there a way that keeps are being compromised beside the client certificate or misuse shared? Agree that we need to have a VPN to access the. No, let me read out the question from Mohammed saying, agree that we need to have a VPN to access the Kube API server. Suppose this wasn't the case. Is there any way Kube API server being compromised beside the client certificate being misused or shared? Very good question, Mohammed. If those ones weren't shared, the only thing I could, think of is vulnerability within the Kube API or itself. So for example, when Kubernetes fix a lot of vulnerabilities. If a vulnerability exists in the Kube API server itself, that potentially could get access to, right? The other one is opening up, which I will go into in a minute. The important part of keeping it private means you are stopping like denial service attack and things like that as well. I hope once again I answered the question. Is my connection and my voice is still breaking up, Shamond, or do you think it's on your end or my end?
No, Kanchana, it's from my end.
Okay. I hope everyone else can hear me. I did have some issues in the morning, but seems to have stabilized. So let me continue. So I was at binary image scanning. So image scanning, the static one is a must. But then add on to that is sign the image as well. What signing the image means, you have scanned and you're putting into private repo. Before you put it in the private repo, you actually sign it saying this is signed by whatever your organization name or so on and so forth with a key, right? That way, when somebody pull that image to deploy into your environment, you know it's only coming from yours and it's signed, right? But then don't leave it at that. because you would find a lot of the stuff at static, but there are runtime vulnerabilities that are happening as well. And the runtime are great. I think Muhammad and the others are saying it's very clear, so that's good to hear. So runtime monitoring is important. The reason why the runtime monitoring is important is it could be a code vulnerability in your code that you're running in the container, or it could be a vulnerability that happens since the static scanning has done, right? Or the code is actually trying to do, application code is trying to do what you're not supposed to do, right? To call some system, syscalls and things like that, right? So again, think about runtime monitoring and alerting. Cisco, Sysdig Falco allows you to do that, and there are other tooling like EchoSec and NewVector, Twistlog as well that allows you to actually monitor them at runtime as well. And monitoring isn't enough, so you have to have alerting and also action behind the alert as well. Overall, what it would help is if you shift the security to the left, right, with the right processes and control in place. Just because you have all these, if you don't also have the process in place to do, if something like this happen, then obviously, it's not going to help. Right? Can we create a cluster for VoIP and PBX? Achala, can we create a cluster for VoIP and PBX? Do you want to elaborate that? Because I think, I guess, you could, if there are containers that can write VoIP or PBX services, obviously you can. I'm not quite sure about the question. Maybe you can elaborate a little bit more so I can answer that. So moving on, I'll come back to the question, Achila, but if you can elaborate a little bit more, that would help me to answer that in an appropriate way. Lazy observability, right? So assuming that you kind of done all the good things that we discussed earlier, but you're not, doing any observability at all, right? Security, information, events management, right? Which is what SIEM stand for. If you're not doing that, you don't know what's going on. You think that my cluster is secured, and it may also be too late by the time you know something has happened. So obviously what you don't want to do is, reacting to something. Right? So preventing it, have monitoring, logging, alerting, all security activities. Some organization call this CSOC, where they collect all the logs with regards to security. Other organizations call it Security Command Center. In Google Cloud, you have the Security Command Center. Azure and AWS has the similar ones as well. Reporting into that, and like I said, report plus an action behind it, what needs to be done, right? And again, if you can't afford commercial SaaS or installable products, you can use open source software for doing that as well. Prometheus, Grafana, and Prometheus Alerting are tools that you could combine with Sysdig, Falco, and Trivi and other tooling. Obviously, of course, there will be a little bit of integration to be done, or you could use a commercial SaaS product, right? But don't leave that to the last minute, because it could be too late by the time you know what has happened. Let me check. Yeah, I think Ashad already answered, but yeah, if they are available as containers, you can run them, but be very careful asterisks and those ones tend to keep ports open without, unknowingly, right? So make sure that if you're deploying those ones, you have those security stuff that I just discussed earlier in place in your cluster, so you're fully protected. Denial attacks. So going back to Mohammed's previous question, if you have Kube API, let's say, exposed externally, you may not have Kube config leaked or available externally, but your endpoint is available externally, and easily you can have denial attacks, right? And with denial attacks, what they look to do is to see if we attack hard enough, if things might break, they give them a backdoor to enter into systems, right? And so my recommendation is always put the Kube API in a private VPC if you're running in Google, Amazon, or Azure, or even DigitalOcean if that is possible. But the last time I think I checked, DigitalOcean did not have a firewall behind the Kube API. However, you could have authorized IPs that soak into that API. That minimally do that if you're using like DigitalOcean or other services that you can't put a private VPC. Otherwise, have the private VPC, have a base station host, and you don't even need the VPN. You could log into the base station host, and then because you're now within that, that way you can prevent that denial attacks, right? Consequences can be catastrophic. And the reason I'm saying catastrophic is your cluster may have 100 nodes, 5 nodes, but it could have services that are connected in other clusters that have no Kube APIs externally exposed. And a hacker could potentially, the denial service could go into some of those services as well, right? So make sure when you do that, if you are exposing externally, to have an authorized network only coming into it. If you can't do that, then I guess you'll have to have some level of monitoring to make sure that you are preventing the denial attacks. If you're doing the right thing, then do not expose and have web access firewall in front, manage load balancer. Normally, they would actually prevent DDoS attacks. Even to a certain extent, DigitalOcean also might actually warn you, saying that you're seeing unexpected traffic coming into your cluster, and they probably, to tell you to actually shut it down for a little while, or change the IP address if that is possible. So to summarizing, Achala did ask another question. Most clusters run with the API management. I need to create a cluster to support VoIP and PABX. VoIP is, voice over IP. PABX means private branch, all related to telephone system support. Yes, Achala. I think these things, like Zachariah also said earlier, you can run them as containers. If you do have an API gateway to access to those ones, to the VoIP and the PABX, if they have APIs, enable the API gateway, have the right API gateway management, enable like throttling, tokens, the authorization security, all that, the good things that comes with API gateways, accessing those services. But that doesn't mean that you need to have Kube API exposed externally. what you're talking about here is exposing the APIs of the VoIP and the PABX system. And the best way to protect them is, yes, you're right, run through the API gateway, and have the best practices apply for the API gateway. I hope that answers your question, Achla. Yeah, so from a logical architecture perspective, it's best to kind of categorize into different zones where you run things. So in here, I have, sorry. So internal users, so these are like, yourself doing it, accessing through a internal user gateway. This could be a base station host, or it could be an internal gateway that have access to give you private VPN access to the Kubernetes cluster. External users typically, unless they're doing some contracting work or work for you all, you shouldn't allow the external users any direct access to Kube API. If you ever want to give a Kube API access, you could use an API gateway, or you could use a WAF, or otherwise, which I haven't drawn here, you could also have a separate, like a VPN for the third-party accesses. Normally, enterprises wouldn't allow you to have direct access through the normal access that your internal users are accessing. The laser pointer keeps going up. So yeah, so create different zones for internal users and external users, and have the centralized operations like your identity and access management. It could be Active Directory, so on and so forth. Your DNS as well, and a secret management like HashiCorp Vault or CyberArk, Conjure, and a few other things. But HashiCorp Vault seems to be the most popular one for Kubernetes environment. So use them, and use them as centralized operation tooling. Do not put it in the same cluster as the cluster that you're running, but they should stay outside of the cluster and centrally manage and control. Similar, the observability. Obviously, you are running agents and so on and so forth to collect the monitoring, logging, alerting, and tracing data, but have the observability outside of your Kubernetes cluster, because the last thing you want is if somebody get access to your cluster and start controlling it, you don't want your observability and centralized operations to be taken over. Right? Because if that happens, then there's no point of having any observability or any of the central management stuff. So when you start designing it, development environment, you could have everything together, but importantly, you should start thinking about going into day two operation. How am I or our team going to manage it, having them separately? And if you have these going, I think you could be having a nice day two with less issues in terms of security concerns, so on and so forth. But once again, having it set up is one thing, but having those processes in place to make sure that actions are taken, things are kept up to date, so on and so forth, is also really, really important as well. That is the last slide, I believe, in terms of before going into security, and one last very small video that I like to share with you all. But any questions at this stage before I kind of play the video and give credit to some of the people that had helped me putting together the slides and so on and so forth.
We got a question from Nilesh.
Should we answer Nilesh's questions or not? Okay. The question from Nilesh is, any Kubernetes security related research projects for undergraduates? Really good question, Nilesh. I strongly suggest, unfortunately, it might be, it's still not too late to sign up. It's happening tomorrow and day after, which is the eBPF conference. And eBPF is becoming really popular in Kubernetes observability. And if you all can, go to eBPF.
.io, right?
Actually, I can open it up here. Let me just quickly. Yeah. Does the second screen come up as well? Probably not, right?
No.
Okay, let me stop for a minute. Can you see it now?
Yes, consider now it's visible.
Yeah. So EBF conference is happening tomorrow. So I think it's probably in the Sri Lankan time, probably maybe in the daytime. For me, it's very early in the morning. If you go to ebpf.io, you can go register, and there are fantastic talks around it. And the reason I'm saying is Falco, Aquasec, and Sysdig, Aquasec, and others are looking at using eBPF to actually do observability. Yeah. I hope that answers the question, Nilesh. And in terms of research topics, I can think of few and probably maybe share a little bit later on. But there are some really good stuff happening in the eBPF if you look at the projects that the university students and others can contribute to, and so on and so forth. There's another question from Mohammed. What are the mechanisms to achieve accountability in Kubernetes cluster? Accountability, do you want to elaborate this in accountability in terms of who does what, or? Okay, I'll assume if it is who does what. So I guess you can draw boundaries in terms of who does what. I guess the coming from the traditional and moving into the new agile kind of development environment, the things have changed rapidly. So if you're a developer, your responsibility doesn't stop at just purely deploying the application and forgetting about it. So, okay, all right. So you said yes, yeah. So as a developer, you should also consult and work with the DevOps engineers to make sure, you are taking the security mindset left. That way, when you deploy an application, it has been scanned, it has gone through all the good security things as opposed to before it gets into production, right? And then the DevOps engineer's responsibility is to ensure that you have those CI/CD tooling, scanning tooling, so on and so forth in place. And the SRE engineer's responsibility is to make sure that monitor and watch those observability stuff in terms of improving your application as well. And if they can help you and the DevOps engineer to come back and say, you're supposed to look at these touch points because you have limited security aspects, right? So it's very broad, it's very high level, Mohammed. But if you do want to, probably maybe Chamod, I can share some really good links, talks about separation of duties. Recently, there was an article by Amazon Architect in Newstech. I'll find that article and I can share that with you all. That has really clear boundaries. Once again, while I said it's clear boundaries kind of doesn't really, you can't draw a hard line as such, right? In terms of who does what and so on and so forth. Obviously, the developers aren't going to go and actually play with the production environment infrastructure. Having said that, but all the other good things that you're supposed to do, unlike in the past, it's not develop and throw it over the fence kind of thing. You have soft boundaries. But I think that article would help you because it has a really nice drawing as well, which I'll share later. Yeah, we can share it via the Twitter or via the Facebook, right, Shamod?
Yeah.
The link. Yeah. Okay. I hope that kind of in some ways answer your question, Mohammed. But I think given the time and everything, what I would do is I will actually share that with you. If it is important in a future session, me and some of the others, we could have a panel session and explain some of those aspects. Okay, so if you really want to be secure, I got this video. It is kind of very funny, but just carefully listen to it. So think of this is about a credit card, but think of this as if you're implementing security in Kubernetes. Okay, I'm going to stop talking and play the video. Chamod, let me know if the sound comes out as well.
As you know, our security chip helps reduce credit card fraud for our customers.
Yeah, I can hear the sound. Yeah.
You can hear the sound, okay.
Yeah.
Right. Let me play from the beginning then.
Welcome aboard, Kate. As you know, our security chip helps reduce credit card fraud for our customers, but I'm confident you can reduce it even more.
Is that the Falcon?
Oh, yeah. You want to see? This is our division. Large fries. Light. Someone let me in. Great.
ANZ cards.
So I hope you got the gist of it. What it's kind of, it was for credit card, but if you think about it, it went through the layers. That person scanning from different levels, and obviously at the end that he had the key, but he couldn't still get into it. If you think of it like that, you have many, many layers. And if you really want to get to Kubernetes clusters, you need to talk to someone internally to get it access, right? If you can enable and think of that way, not obviously, somebody from inside the Kubernetes cluster has to give you a key. But if you think about that concept, it's a funny video, but it's actually kind of summarized in a very nice way. With that, if there are no more questions, I'm happy to wrap up. And once again, Chamod, thank you so much for organizing it. And I hope it was a useful session for everyone.
So then let's wrap up the session.
Okay, and I'll make the PDF of the. Thank you, Nilesh. I will make the PDF, and where do we normally share it, Chamod? We share it.
Usually we share it on Facebook.
Okay, all right. So I'll create a PDF and send you the PDF.
Okay, yeah. I will share.
And with the other links I spoke to you about. Yeah. Okay.
Okay.
All right. Enough with that, Nilesh. Okay. Thank you, everyone. Good night and a good evening for you all.
Thank you very much, Kanchana. Thank you for everyone who attends to today's Kubernetes Sri Lanka meetup. Stay safe. See you next time.